SQA Advanced Higher Maths 2024 Paper 1. This will be the full solutions. Let's get started straight away. Higher Maths 2024 Paper 1. Question 1. Differentiate the form with respect to x, y equals cot 3x, and y f of x is 5x, 4x minus 7.5. So part A, we've got the chain rule to do here. So we've got the y by the x, and you check the start of the exam paper, and cot goes to cosec. So I've got cosec squared 3x, and then I like to times by that 3. So 3. So minus 3 cosec squared 3x. Just check that at the start of the exam paper. Cot goes to minus cosec squared. So yeah, that's fine. Right, part B, f of x is 5x, 4x minus 7.5. So a nice little product rule here, f dash x. So we've got uv, so it's vu dash, remember, so u dash is 5, and we'll just keep v as it is, plus u 5x times v dash, so that's a half, 4x minus 7 minus a half, and 8 times by the derivative, which is 4. So tidying that up as much as we can or want to. We've got 5, 4x minus 7 to the half. Half of 4 is 2, 2 5s is 10. So 10x, 4x minus 7 to the minus a half. And I think you'll probably get your marks there. You could probably go one step further and take 5, 4x minus 7 to the half out as a common factor. But you can end up with a messy thing in the middle. I'll show you what I mean. I could do 5, 4x minus 7 to the half, or even to the minus a half if you prefer. And that would give me just 1 plus 2x. And I would have 4x minus 7 still. And then I want to have a number which is minus 1. Half minus 1 is minus a half. So yeah, that's a little bit messy. So I think part B is fine. SQA Advanced Higher Maths 2024 Paper 1 Question 2. If the complex number is defined as z equals 1 plus I, express it in polar form. So to do polar form for part A, I want the size of z. Well, that's just the square root of 1 squared, and it's 1i plus 1 squared. 1 plus 1 is 2, so that's root 2. And then we want to find tan theta, because remember, if you think of this on a diagram, you've got 1, 1 here, and you can imagine there's your theta there. So it goes along 1 and up 1. So that means that tan theta equals 1. And that means that theta is the inverse tan of 1, which is pi over 4, 45 degrees. Because it's an exact value. So now we can just express it in the correct form. Z equals root 2. And then you've got cos theta, which is pi over 4, plus I sine theta, which is pi over 4. And just check on the principal argument. You probably don't need to be, but remember that's between minus pi and pi. So yeah, we are. So we're done there. Part B says, use the Moivre's theorem to do ZA. And it says evaluate it, so work it out. So ZA is root 2 to the power of 8, cos 8 pi over 4, plus I sine 8 pi over 4. Simplifying that out, well, root 2 times root 2 to the power of 8, well, root 2 times root 2 is 2. So that's the same as 2 to the power of 4. Cos 8 divided by 4 is 2 pi, plus I sine 2 pi. Now, if you're leaving it in this form, you would actually put it back in the principal argument, but actually have to evaluate it. So we might as well just go ahead and evaluate it. 2 times is 4 times 2 is 8 times 2 is 16. The cos of 2 pi, well, 2 pi is 360 degrees. That is equal to the cos of 0 as well, which is 1. So that's just 1. And the sine of 360, well, 360, that gives me 0. So plus 0. 16 times 1 plus 0 is 16. And we're done there. SQA Advanced Higher Maths 2024, Paper 1, Question 3. A geometric sequence has positive terms and SQA Advanced Higher Maths 2024, Paper 1, Question 3. A geometric sequence of positive terms has the third term 36 and the fifth term 16. Find the common ratio. So geometry equals AR squared, AR cubed, and so on. So AR squared is 36. And similarly, AR cubed, AR4 must be 16. Where R is the common ratio, so we just divide them together. AR4 over AR squared is 16 over 36. And 4 goes into both of them. 4 4s is 16 and 4 9s is 36. So dividing that through, R squared is 4 ninths, which means that R is equal to the square root of 4, which is 2, over the square root of 9, which is 3. 2/3, and we're done there. Part B says, calculate the value of the first term. Well, the first term is A. So just using AR squared equals 36. A times 4 ninths, because that's R squared, equals 36. So A equals 36 divided by 4 ninths. 36 times 9 quarters. Well, 4 nines is 36, so that's 9 times 9, which is 81. So the first term is 81. And then the last bit says, C, state why it has a sum to infinity. Well, this was B, by the way, and that was A. C, it has a sum to infinity because minus 1 is less than 2/3, which is less than 1, in other words. So that's all you need to say. Question D. I'll just put therefore the sum to infinity exists. Question D. Find the value of the sum to infinity. So the sum to infinity for this sort of sequence is A over 1 minus R. So A is equal to 81 over 1 minus 2/3. 81 divided by 1/3. That's 81 times 3 then. 3 ones is 3, 3 eights is 24, 2, 4, 3, and we're done there. SQA Advanced Higher Maths 2024, paper 1, question 4. Matrix A has this, 6, 1, 11, 3. Find the inverse matrix. Okay, the inverse matrix is equal to 1 over the determinant of A times 6, 3. Change position, 3, 6, and the other one stay where we are, but I move the sign. So what's the determinant A then? Well, it's 6 times 3 minus 1 times 11, the diagonals. That's 18 minus 11, which is 7. So that means that the inverse matrix is a 7th of 3 minus 1 minus 11, 6. And we're done there. Part B says, find the matrix M such that AM equals B. There's a couple of ways to do this, but I think the simplest way, especially when we've got the inverse already, is to start with the fact that AM equals B. We can put an inverse here, and then just put it here. Now make sure you put your orders in the right place. I put it in front, so I put it in front. A inverse A is I, so IM equals A inverse B, but I times M is M. So M is just A inverse B. So A inverse was 1/7, 3 minus 1 minus 11, 6, times B was minus 4, 3 minus 5, 2. Times everything through, we get 1/7. 3 minus 12 plus 5 is minus 7. 3 3s is 9, minus 2 is 7. 40 minus 30, 44 minus 30 is 14. And then minus 33 plus 12 is minus 21. So we get minus 7, 7, 14 minus 21. So then we just divide by 7 then to get minus 1, 1, 2 minus 3, and we're done there. SQA Advanced Higher Maths 2024, paper 1, question 5. A function is defined as f of x equals x cubed minus x. Determine whether it's odd, even, or neither, and then show that it's got a point of inflection. So part A. If we want to show that it's odd, even, or neither, we're going to have to examine f of minus x. So subbing that in, that's minus x cubed minus minus x. So minus x cubed is minus x cubed plus x. So minus x cubed plus x, well, what happens if I put a minus here? I get minus x cubed minus minus plus x. So that's equal to minus x cubed minus x, which is minus f of x. So as f of minus x, equals minus f of x, we can see the function is odd. And we're done there. Show that a graph of f of x as a point of inflection. So if we're going to get a point of inflection, we're going to examine the second derivative and see whether it's undefined or 0 at some point. So f of x is x cubed minus x. F dash x then, of course, is going to be 3x squared minus 1. F double dash is going to be 6x. So possible inflection when 6x equals 0, so x equals 0. And then we can just examine whether there is a change in concavity or not by just drawing a little table for ourselves. So we're going to go along, either side is 0. So as we approach, so in other words, 0 minus, 0 plus, we're looking at the second derivative here. So just before, when it's minus, well, 6 times a minus number is a minus number, so that's negative. That's 0. And just after 0, like it's tiny little bit, it becomes positive. 6 times positive is positive. So you've kind of got this. So it is a change of concavity. So therefore, change in concavity therefore point of inflection exists. And that's that one done. Advanced Higher Maths 2024, paper 1, question 6. Find the 2 by 2 matrix A associated with a reflection in the x-axis. So you can draw yourself a picture if you're going to get stuck on this. Imagine a point, x and y. It's getting reflected over the x-axis. X stays the same. We've got minus y. So you can think of this as something times xy equals x minus y. And what's a 2 by 2 matrix? Well, 1 times x is x, 0 times y is y, so that will give us x, and we want minus y, so we want 0x, and we want minus 1y. So there's our matrix, 1, 0, 0, minus 1, and we're done there. Describe a transformation associated with the matrix 0, 1, 1, 0. So we've got 0, 1, 1, 0 as our starting position. That's getting times by x, y. So we've got 0 times x is 0 plus y. That gives me a y. 1 times x plus 0y gives me an x. So if you can't see it yet, imagine you've got a point along x up y, say, x, y, and then y becomes x, so along y up x. If you roughly draw it roughly accurate, you should be able to see you're getting a reflection of line y equals x, if you didn't know. So reflection in line y equal to x. Part B, find a 2 by 2 matrix called C associated with reflection followed by a transformation associated with 0, 1, 1, 0. So just remember when you're doing these, you actually work backwards from the finishing point. So I start with 0, 1, 1, 0, and I times by my 1, 0, 0, minus 1, because that's the first thing. So 0 times 1 is 0, 1 times 0 is 0, so that's a 0. 0 times 0, and 1 times minus 1. 1 times 1, and 0 times 0. 1 times 0, and 0 times minus 1. So we get that matrix. It doesn't ask us to say anything about it, so I'm done there. Maths 2024, paper 1, question 7. A curve is defined by this equation. Use implicit differentiation to find the y by dx. So we've got x squared y, so that is the product. So I'll do v u dash, so y times 2x, plus u v dash x squared y, so it becomes the y by the x. Similarly for 4xy squared, I'll call 4xv, and then v u dash y squared becomes 2y, the y by the x, and then plus v u dash y squared times 4x is 4, and that equals the derivative of minus 32, which is nothing. So tidying that up, we've got 2xy plus x squared dy by dx plus 8xy dy by dx plus 4y squared equals 0. The y by dx here, and I've got x squared plus 8xy, and that equals minus 4y squared minus 2xy. And then we can just divide by whatever the y by the x is times by. So that means that the y by the x is minus 4y squared minus 2xy all over x squared plus 8xy. And we're done there. Only one stationary point. Find the coordinates of the stationary point. So the y by the x equals 0 for stationary points. So part B, stationary points. The y by the x equals 0. So if the y by the x equals 0, and that's our expression, then that times that is 0, so the top is just 0. So 4 minus 4y squared minus 2xy is 0. So let's see if we can take a common factor. Well, we can take 2y out. So that gives me minus 2y and minus x. So that means that 2y equals 0 or minus 2y minus x equals 0. So y equals 0 or x equals minus 2y. But it can't be that one, simply because there's only one stationary point and y is greater than 0. So it is the other one. So if x is minus 2y, we can just sub it back into the original equation. So we've got x squared y plus 4xy squared equals minus 32. So minus 2y squared times y plus 4 times minus 2y times y squared equals minus 32. So 2 twos is 4, so that's 4y cubed. 4 twos is 8, so that's minus 8y cubed, and that's minus 32. So minus 4y cubed is minus 32. So y cubed is minus 32 for 4. 4 eighths is 32. So y must be 2, because 2 times 2 times 2 is 8. If y is 2, then x equals minus 2 times 2, which is minus 4. So the stationary point equals minus 4 and 2. And we're done there. SQA Advanced Higher Maths 2024 paper 1 question 8. Use the substitution u is tan 2x to evaluate this integral. Okay, let's start with u equals tan 2x then. So we're going to have to get rid of the dx anyway. So even if you don't know what to do, you should just start with that. du by dx. Well, sec squared 2x. Start of the exam paper, if you don't know, times it by 2 because of a chain. So that means that dx times that is du. So dx is du over that 2 sec squared 2x. Now you might not be able to see what's going on, so just sub it in and see what happens. So let's have a look. Root tan 2x, well, u is tan 2x, so that's the root u I've got. And then we've got cos squared 2x on the bottom. I don't know what the hell that is, so let's just leave it where it is. And I'm timesing that by du over 2 sec squared 2x. Well, that's root u over cos squared 2x times du over 2 times, well, sec is 1 over cos, third letter, helps to remember that. So 1 over cos squared 2x. Well, that's handy because we just cancel each other out. So that gives me root u du over 2. So now we can do our limits. So we've got 0 and pi over 8. So when x equals 0, u equals tan of 0. And the tan of 0 is 0. And when x equals pi over 8, u equals tan, it was 2x, I think. So 2 pi over 8, which is pi over 4. Pi over 4 is 45 degrees. The tan of 45 is 1. So that means our integral just becomes the integral between 0 and 1 of root u du over 2. So that's a half of the integral between 0 and 1 of u to the half du. So what does that give me? That gives me a half. Add 1 to the power. Divide by the new power. 3 halves. becomes 2/3. And that's between 0 and 1. So subbing in our numbers, that's a half. 2/3 times 1 to the 3/2 minus 2/3 times 0 to the 3/2. That's just a half times 2/3 then, because 1 to the power of anything's 1, and then I've got 0. That's just 2/6, which is 1/3. And we're done there. So SQA Maths today, we've done the whole of SQA. This has been SQA Maths today, we've done the whole of SQA Advanced Higher Maths 2024 paper 1. Hope you find that useful. Paper 2 coming soon. Hopefully when it is, you'll be able to click the video here straight away. Take care, stay safe, and goodbye.